Dear students, next we have to study the shape function for one-dimensional elements. We already studied the concept of shape function. Shape functions are mathematical functions which are used to find out the unknown values of field variable in an element by manipulating it with the non-nodal variables. In the case of one-dimensional elements, that is, so this is an one-dimensional element. This is node number 1, this is node number 2. And here the displacement is u1 and here the displacement is u2. Then using the shape functions, the displacement at any point can be represented as u is equal to n1 u1 plus n2 u2, where u1 u2 are non-nodal variables, and n1 n2 are shape functions. In other words, the non-nodal variables are u1 and u2, and n1 and n2 are the shape functions. Okay, where n1 is equal to 1 minus x by L and n2 is equal to x by L, where x is the distance of any point in the element from the first node. Okay, now we have to derive these shape functions. So already we studied, this is the one-dimensional element, this is node number 1, this is node number 2, and here the displacement is u1 and here the displacement is u2. Okay, in the case of one-dimensional elements, the displacement at nodes are linear. Okay, that is along this direction. At node 2, the displacement is along this direction. At node 1, the displacement is along this direction. Either this direction or this direction. Here also either this direction or this direction. Whatever may be, this is in a line. Therefore, displacement at any point can be generally represented as u is equal to, represented using a linear equation, u is equal to a0 plus a1x. U is equal to a0 plus a1x. Okay. Let the length of this element is n. Okay. So from this, when x is equal to 0, that is already I said x is the distance of any point in the element from the first node. Okay. So when x is equal to 0, u is equal to u1. When x is equal to L, u is equal to u2. That is u2 is equal to a0 plus a1 into L. Here you will get that is u1 is equal to a0. Okay. So u1 is equal to a0, u2 is equal to a0 plus a1 into L. So this is equation number 1, this is equation number 2, and this is I am putting equation number 3. But from this relation, u1 is equal to a0. Therefore, u2 is equal to u1 plus a1 into n. That is, a1 into n is equal to u2 minus u1. That is, a1 is equal to u2 minus u1 divided by n. So this is equation number 4. So our general equation is to a0 plus a1 into x. Then this u is equal to this u1 plus, in the case of a1, the value is u2 minus u1 divided by n into x. That is, u is equal to u1 plus u2 into x divided by n minus u1 into x by n, and which is equal to u1 into 1 minus x by n plus u2 into x by n. Here u1 is common, that is why u1 1 minus x by n plus u2 into x by n. Okay, which is equal to u1 into n1 plus u2 into n2, where n1 is equal to 1 minus x by n and n2 is equal to x by n, which indicates that displacement at any point in an element can be represented as u is equal to n1 u1 plus n2 u2. This is representation of displacement of any point in an element with respect to the non-nodal variables, where n1 and n2 are the shape function. Okay. So if we are putting the values for this x, we will get the value of u at any point. Thus we got n1 is equal to 1 minus x by n and n2 is equal to x by n. From these two relations, we can see that n1 plus n2 is equal to 1. This is one of the properties of shape function. Also, if you are considering this element, the variation of n1 is that at node 1, n1 is maximum 1. At node 1, n1 is equal to 1, because while we are putting x is equal to 0, n1 will be 1 and it will be reduced towards node 2. And if we are considering the n2, we are considering the variation of n2 at node 2, which means that x is equal to n. At node 2, the value of n2 is equal to 1, which decreases towards the node number 1. So that's all about the derivation of shape function in an one-dimensional element.